I am Muhammad Shahbaz Alam, Assistant Professor from ABES Engineering College, Ghaziabad. Welcome students. Now I am going to discuss the lecture 7. In lecture 7, I will discuss the application of p-n junction diode, that is caliper circuit, and what is caliper circuit and how it works in various conditions. First of all, what is caliper? It is a circuit which removes the unwanted portion of any input signal without distorting the remaining signal. This means, if this is a caliper circuit, suppose this is the block diagram caliper circuit, if input is a sinusoidal signal, then what are the expected outputs? These are the expected outputs, and so many others are also possible in caliper circuit. This means we can see that in this circuit the negative half cycle has been removed, in this waveform the positive half cycle has been removed, in this circuit a partial negative portion has been removed, and here the positive partially positive portion has been removed, but the remaining portion is undistorted. It is the condition that remaining portion of the output of caliper circuit should be same as it is in the input waveform. Depending on the output waveforms, there are various types of caliper circuit, that is positive caliper, negative caliper and bidirectional caliper, depending on the output waveforms. But on the basis of circuit designing, whether the diode is connected in the series with the load or whether the diode is connected in parallel with the load, there are basically two types of caliper circuit, that is series caliper circuit and parallel caliper circuit. Further, series caliper circuits are classified into two categories, that is positive caliper. If positive portion, positive half cycle or partially positive half cycle is removed, this is called positive caliper. If negative half cycle or partially negative half cycle is removed, this is called negative caliper. On the other hand, parallel calipers are of three types, that is positive caliper, negative caliper and double ended or bidirectional caliper. This means parallel caliper has an extra type of caliper, that is bidirectional caliper, because in the bidirectional caliper there are two diodes are connected in anti-parallel. This means this bidirectional caliper or double ended caliper is also known as, sometime it is called limiter. Now I am going to discuss one by one circuit in detail. Now first of all, the caliper, series caliper. A caliper circuit in which diode is in series with the load. This means diode is connected in series with the load. The simplest example of series caliper is a half wave rectifier. You can see that this is also the circuit diagram of half wave rectifier. This means this is a simple unbiased negative caliper. This is called unbiased negative caliper. This is a signal square wave. This is positive half cycle and this is negative half cycle. When the input is positive half cycle, then what will happen here? The diode become in forward bias, and when the diode is in become forward bias, then it starts conduct in this loop. This means the output voltage will become the equal to the positive half cycle also, because when we will apply KVL, then what will happen here? Here KVL is V input minus, if diode is ideal, then minus 0, then minus V naught, this is equal to 0. This implies V output is equal to V input. This means the output is equal to V input. Since in this condition the input is only positive half cycle, this means the output will be only the positive half cycle. This means jaisa input vaisa output. This is the working of positive half cycle. On the other hand, when the input is negative half cycle, then what will become? That is diode become in reverse bias. This means case 2 for negative half cycle, diode become in reverse bias. Reverse bias means open circuited. Open circuited means the simplest circuit is this diode become open circuited, and this is the resistance and this is the output terminal, and here input is only negative half cycle. Negative half cycle. This means what will happen here? This means the current flowing through the circuit is 0. Current flowing through the circuit is I is equal to 0. This means V output is equal to I into RL. This is equal to 0. Why 0? Because I is 0. This means for the negative half cycle the output become 0. The overall output after the complete cycle is this. For positive half cycle output was just this, and for negative half cycle the output become 0. This is the output of this circuit. Okay guys, since we can see that the negative half cycle has been removed, that is why this circuit is called series negative caliper. Now I am going to discuss the another circuit. Just we have connected a bias voltage V along with the diode. This means this circuit is also called series caliper with a DC supply, or you can say biased negative caliper, series biased negative caliper. And biased here diode is reverse biased with this bias battery V, and the V, this means the negative plate of the battery V is connected with the P type. That is why this is called reverse bias with the voltage V. Okay. This means each circuit has 3 combinations, one is unbiased and 2 is biased. Out of 2 biased, one is reverse bias and another one is the forward bias with the DC supply voltage. Then this is the series caliper with the DC power supply. In this circuit we can see that if V voltage is not here, then what will happen? For positive half cycle the diode will be in forward bias, but here since the diode is reverse bias with the voltage V, this means when input voltage is greater than V, then only the diode will become in forward bias, otherwise it will remain in reverse bias. This means there are 2 cases also. When input is greater than V, the diode become in forward bias and it will starts conduct, and when input is less than V, the diode become reverse bias. This means we will explain it in 2 cases. Case 1, when V input is greater than V, what will happen? Diode is become forward bias, and yes, this was the V, and diode become ideally short circuit, and this is the load resistance RL, and this is the output terminal plus minus, and current flowing through this, and this is minus plus V, and here input is greater than V, like this V, and here Vm, and this is the input. Okay guys, what will happen here? If we will apply KVL, then we get V input minus V, since diode is ideal, that is minus 0 minus V naught, this is equal to 0. This implies V output is equal to V input minus V. This is the equation for output voltage. When input is V, the output voltage is 0. When V input is Vm, then output voltage is Vm minus V. Okay guys. Now case 2, when input is less than V, then what will happen, or you can say equal to V, then what will happen? Diode is in reverse bias. Okay guys, then diode is open circuited, then in this case what will happen? Diode become open circuited, and this is the RL, and this is plus minus V naught, and here yes, here input is here input is less than V, this means this is the input V 0 and minus Vm, this is the input, and here since current is 0, this means output voltage is also 0. Current is 0, this means output voltage is 0 into RL, that is this is equal to 0. Then what will be the output waveform? The output waveform is like this. The output waveform is this, because this is 0 and this is the Vm minus V output. Okay guys, this is the output voltage. This means the peak value of the output voltage will be reduced by the bias voltage V. Okay guys, when the diode is in forward bias, then only we will get output voltage. Now the third circuit is the series clipper with DC wire supply, but here the bias voltage is connected such that the diode become forward bias. Here you can see that positive plate of the bias battery is connected with the P type. What will happen here? If battery is not there, then what will happen? For positive half cycle, diode become forward bias, for negative half cycle the diode become in reverse bias. But here what will happen? For positive half cycle, the diode is forward biased by both the voltages, by the input voltage as well as the bias voltage. If input is 0, but the diode conducts due to the bias voltage, this means when input is negative half cycle and voltage is up to minus V, the diode become in forward bias. This means there are two cases. When input is greater than minus V, the diode become forward bias, and when input is less than minus V, the diode become reverse bias. Only two cases, I will discuss it in two cases here. Case 1, V input is greater than, you can take equal to minus V, then diode become forward bias. Diode become forward bias. Then in this case here diode becomes short circuit ideally, and this is the load resistance, this is plus and this is minus, and this is RL and this is plus minus V, and here the input is greater than minus V. greater than minus V, 0 and Vm, V input. And here conducts. In this case, when we will apply KVL, then what will happen? V input plus V minus V naught, this is equal to 0. This implies V output is equal to V input plus V. Guys, I want to discuss one more extra point. If you are assuming the diode practical, then you have to take here minus 0.7 volt. This means here minus 0.7, this means V naught is equal to V input plus V minus 0.7 volt. This means there you guys have to take 0.7 volt extra here in consideration when you are applying Kirchhoff's voltage law. Now, this is the equation of output voltage when the diode is in forward bias, and when the diode is in forward bias, when the input voltage is in between minus V and plus Vm. For case 2, what will happen? When V input is less than minus V, what will happen? Diode become reverse bias. Reverse bias means diode is in open circuited, here open circuited, and this is V naught, and input is here less than minus V up to minus Vm, and this is 0, and this is V input plus minus, and this is T. What will happen? Output become 0. Why 0? Because current flowing through the load resistance is 0. That is why output voltage is 0. This means what will be the final output of this waveform? The final output of this waveform is like this. Suppose this is the input, this is 0, this is Vm, this is minus Vm, this is axis, and this is minus V, and output voltage is yes. What was the equation of output waveform? The output waveform V naught is equal to V input plus V, and the range of the input voltage is minus V should be less than equal to V input and less than positive Vm. This means for this portion only the diode is in forward bias. This means when V input is minus V, then what will happen? Output is 0, minus V here, these 2 point output voltage is 0, and when V input is 0, then what will happen? Output voltage is, when V input is 0, output voltage is plus V, output voltage is plus V, when input is 0, this is the plus V, and here also plus V, and when input is Vm, then what will happen? And here also input is 0, so this input output voltage will be V, and when V input is Vm, then what will happen? Output voltage is Vm plus V, this value is Vm plus V, and now this is the output waveform. This is the output waveform. You guys can also draw using this output equation, that is, this is the output waveform. Okay, guys. Now, I am going to discuss the positive caliper. I have discussed the all 3 types of series negative caliper. Now, in the same way, these are the positive series positive caliper. This is the unbiased case, and already I have discussed all the 3 circuits of negative calipers. So, in the same way we can also explain the positive clipper here. This is the unbiased case, simple circuit. In this circuit, when we input is negative half cycle, then the diode is in reverse, is in forward bias, and the diode gets conduct, and in this case output is equal to input. This means since input is negative half cycle, this means output is also negative half cycle. On the other hand, when input is positive half cycle, diode is in reverse bias, this means output voltage is 0. In the same way, we can explain this circuit also. This is the bias circuit, and we can explain this circuit. Okay guys, and now this is the third circuit. Also you can see that the diode is in forward bias. We can also explain this circuit also. So there are 6 circuits which are series clipper, 3 negative clipper and 3 positive clipper. Now I am going to discuss the parallel clipper. It is the very simple circuit, parallel circuit, and here the unbiased case. This means in parallel circuit there are 7 circuits there. For simple circuit, for positive half cycle, diode is in forward bias and it will get conduct, and the diode become ideally short circuit, the output become 0. And for negative half cycle, the diode is in reverse bias and diode become open circuit. In this case, output is equal to input, then this is the output waveform. On the other hand, there is a bias battery V is connected here. In this circuit, when input is greater than V, the diode is in forward bias and diode becomes short circuit ideally, and the output is equal to the V exactly. If the diode is practical, then here the output voltage is V plus 0.7 voltage here, and when the input is less than V, then diode become reverse bias and output is equal to the input signal. And here same circuit is here, and here the diode is forward bias with this bias voltage V, and in this case when input is greater than V, then the diode become forward bias and the output waveform will be like this. So this means there are 3 circuits which are called positive clipper. In the same way, there are negative clippers also, and see in the same way here we can easily calculate the output voltage here. I am going to discuss the simple method to draw the output waveform of any parallel circuit. Guys, you need not to worry. Always students are worrying to draw the output waveform. Just this is the shortcut method. You can see like this. Just calculate the Vt here with respect to ground. What is the Vt? Vt is minus V. This means minus V is the Vt here. It is the Vt, and just you guys have to observe the diode, whether you are observing N type or where you are observing P type. If N type is visible here, you have to remove the negative portion, just you have to remove the negative portion, and your output voltage will be this. If P type is viewing, then you have to remove just above portion of the Vt. Any circuit, any parallel circuit, you can easily draw the circuit. Just I am going to next example here. Suppose here Vt, what is Vt? Vt is plus V. Okay guys, and you are seeing N type here from this point. This means N type. तो आपको क्या करना है, N से नीचे वाले पोर्शन को रिमूव कर देना है, यानी कि V के नीचे वाले पोर्शन को जस्ट आपको क्या कर देना है, रिमूव कर देना, और जो रिमेनिंग पोर्शन हुआ वो आपका आउटपुट वेवफॉर्म हुआ. ओके गाइस, एंड ऑन द सेम वे दिस इज द बाई डायरेक्शनल क्लिपर. तो बाई डायरेक्शनल क्लिपर अगर इसका आउटपुट वेवफॉर्म ड्रॉ करना है आपको, तो ये Vt हो गया, Vt यहाँ पे V1 हो गया, तो यहाँ से चूंकि P दिखाई देगा तो V1 के नीचे आप जो है V1 के यहाँ पे यहाँ से आपको क्या दिखाई दे रहा, Vt इज यस प्लस माइनस, Vt इज हियर V1, तो और P इज V1 के ऊपर आपको यहाँ पे रिमूव कर देना, और यहाँ पे Vt क्या होगा, यहाँ पे Vt होगा V2 माइनस V2, तो यहाँ पे क्या दिखाई देगा N, तो -V2 के नीचे रिमूव कर देना है। तो कोई भी सर्किट हो पैरेलल सर्किट, आप जस्ट VT से आप रिमूव कर सकते हैं। अगर P दिखे तो ऊपर और N दिखे तो नीचे आप उसे रिमूव कर सकते हैं। तो ओके गाइस, दिस इज ऑल अबाउट द 13 clipper circuits, 13 types of clipper circuit. 6 is the series clipper and 7 is the parallel clipper. Okay guys, thank you.